Hello guys, welcome to my channel NCERT Unplugged, and in this video I start a new chapter number 5, Magnetism Matter. I will explain the chapter in English. Okay, so this is going to be English video. So first paragraph, we'll start with the first paragraph, and this is the introduction paragraph. As you know, in this channel I read the NCERT and then explain the line by line meaning of NCERT. So let's start. So magnetic phenomena are universal in nature. So it says that there are so many magnetic phenomena that are present in the universe. We can see magnetic phenomena in the universe. Okay, vast distant galaxies, the tiny invisible atoms, humans and beasts, all are permeated through and through with a host of magnetic field from a variety of sources. So we humans, atoms, galaxies, all are surrounded or permeated through with magnetic field from sources, different sources, known and unknown sources. Okay, so the earth magnetism predates human evolution. That means magnetism is present in the earth atmosphere, or in the universe before the evolution of human. Even before we were evolved, even before that there was magnetic field. The word magnet is derived from the name of an island in Greece called Magnesia, where magnetic ore deposits were found as early as 600 BC. Okay, so where does this word magnet is derived from? So it is derived from an island in Greece. This is an island in Greece, Magnesia, in 600 BC. Okay, so what happens, as you will see now, that there were shepherds who were roaming in the island. They were doing their work. Okay, so sometimes their shoes, which has nails in it, iron nails, they used to stick on some stones. Okay, and so people and those shepherds and the people of Greece come to know that there are some stones which has attracting property, which they are in future called as magnets. Okay, and from there the name magnet come from, because the island name was Magnesia. Okay, so shepherd on this island complained that their wooden shoes without nails at times stayed stuck to the ground. Their iron tipped rocks were similarly affected. This attractive property of magnet made it difficult for them to move around. Okay, so from here magnets were named and discovered. Okay, so directional property of magnets was also known since ancient times. A thin long piece of magnet, when suspended freely, pointed in north-south direction. We all have seen it, or we have seen a magnetic compass, and as you know, in the magnetic compass, this is this is shape of magnetic compass, and there is a small magnet, the magnet needle. If you place it on a surface, you will see that it always point to the north-south direction. You can take any magnet, and if you suspend it freely, it will always point in the north-south direction. We all know all these things. Okay, so this is just an introduction paragraph. A similar effect was observed when it was placed on a piece of cork, which was then allowed to float in still water. Okay, so, and we must have read about this, or we have done this activity, or we must have read this activity, that what we do, we insert a magnetic needle in a cork. Okay, then what happens, and we put it on a water, so it will come to in the north-south direction. Again, it will point to the north-south direction, because we know earth also has magnetic field. Okay, so the name lodestone given to a naturally occurring ore of iron magnetite means leading stone. Okay, the technological exploitation of this property is generally credited to the Chinese. Okay, so from where does this north-south direction property was first found? It was the Chinese who discovered it. Okay, Chinese texts dating 400 BC mentioned the use of magnetic needles for navigation on ship. Okay, so they used magnetic needles for navigation ship to find a direction. Okay, and in 400 BC. Okay, the caravans crossing the Gobi Desert also employed magnetic needle. Okay, so these are the some example from how does the some history about magnet basically. Okay, a Chinese legend narrates the tale of the victory of the Emperor Huang Ti about 4,000 years ago, which he owed to his craftsmen, whom nowadays you would call engineers. This engineer built a chariot on which they place a magnetic figure. Okay, so one of the rulers of China, what he credits his victory to one of his engineer of the craftsman. What he did, the engineer put a magnetic figure, okay, in his chariot. Okay, like this you can see in his chariot he built a figure, and it had a hand. In that hand he what he placed, magnet place, he placed a magnet. Okay, basically, so freely suspended magnet, and you know it always point in the north south direction, so it must have helped him in finding the right direction. Okay, finding the right direction, and it helped in his victory. So we know how important magnet is. There are so many more properties that we'll discover, we know about it. Okay, so this is a very important and basic property. Okay, so you can see how important it has in history, this property of magnet. The figure swiveled around so that the finger of the statuette, if I'm pronouncing it right, okay, sorry for the pronunciation if I'm wrong, on it always pointed south. Okay, so it always pointed south. Okay, so this is a magnet, you know, it's also pointing in the north south direction. With this chariot, Huang Ti's troops were able to attack the enemy from the rear in thick fog and to defeat them. Okay, so there was thick fog, and it helped them to find the right direction. Okay, and hence it helped in the victory of the emperor. So now we understand how one of the use, you can say, in history that has magnet has. Now we'll move to the next paragraph. In the previous chapter we have learned that moving charges or electric current produce magnetic field. Okay, obviously we have run chapter number 4. The chapter name was magnetic charges and moving charges and magnetism. Okay, so in that chapter what we studied magnet as a effect of electric current effect as magnetic field and magnet. Okay, this discovery was made in the early part of the 19th century, is credited to Oyster experiment. We have already seen, Ampere circuit law, all those things. So these are the scientists name, the scientists who are credited for this discovery. Okay, in the present chapter we take a look at magnetism as a subject in its own right. Okay, so we'll not study as like we studied in the previous chapter as a effect of electric current, but as a separate subject, magnetism. Okay, so some of the commonly known ideas regarding magnetism are, and we know all about these things, like the earth behaves as a magnet with the magnetic field pointing approximately from the geographical south to the north. Okay, we know about this. Okay, so that earth also is a magnet. It has magnetic field which is from geographical south to geographical north. We'll understand it more how these names are given in further in the chapter ahead. Okay, and now the second point. When a bar magnet is freely suspended, it points in the north-south direction. If we have already seen this, the tip which points to the geographical north is called the north pole, and the tip which points to the geographical south is called the south pole of the magnet. There are so many confusion on this, and when we learn about it more, we'll understand that this is. I'll just give you an example, and this is what geographical north is. Okay, this is geographical north. Okay, and all the magnet will always point in this direction, so we'll name this as north of magnet, this is south of magnet. This is geographical north and this is geographical south. Okay, so now we can isolate the north or south pole of a magnet, and we cannot, obviously, you know. What happens if you break a magnet? It will become a new magnet. It will have two poles. Monopoles of magnet do not exist, and this is one of the Maxwell equations. Okay, we'll study 4 equations of Maxwell. Okay, first equation is, obviously we have already studied, that is the Gauss's law in electricity. Okay, it's electrostatics. Okay, and the second law is this, that the magnetic dipole do not exist. We'll understand it further. Unlike electric charges, isolated magnetic north and south pole known as magnetic monopole do not exist. Okay, we have seen that electric charges can be isolated. We get electric single charge, but we cannot get monopoles. There will be always dipole of magnet. Fifth point, it is possible to make magnets out of iron and its alloys. Okay, we can make iron. You have studied in the previous in earlier classes that how can we can make a magnet. We can place an iron piece on a magnet and just put it across it so many times, then it acquires some magnetic properties. Okay, and there are other methods also. We begin with a description of a bar magnet and its behavior in an external magnetic field. Okay, so first of all, what we'll study, we'll give the description of bar magnet and its behavior in external magnet field. How, like, it is similar to how we studied a dipole in an electric field. Okay, so if you have understand that, you know about that, it will be very helpful. You will be able to relate all those things in here. We describe Gauss' law of magnetism, just like we studied Gauss' law of electrostatics. We then follow it with an account of the Earth's magnetic field. Then we will understand the magnetic field in detail. We next describe how material can be classified on the basis of magnetic properties. This is very important. Paramagnetic, diamagnetic, ferromagnetism will categorize the materials on the basis of magnetic properties. And lastly, we conclude with the section of electromagnets and permanent magnet. Okay, so this is the introduction paragraph. We have studied what are the basic things that the magnet has, a little about the history of magnet, and what we have to study in this chapter. Okay, so if you that's all for this video. So if you like this video, understand this video, please give it a thumbs up. Subscribe to my channel if you want to get more NCERT videos like this. If you find anything missing on this video, anything any way I can improve my videos, you can surely comment on the comment section. And lastly, thanks for watching.